the Z table backwards, forwards. So let's make sure we're all on the same vocabulary. So okay, so the z-score, just reviewing them, we're going to work on some stuff. So the z-score, for the most part, is basically taking your standard deviations and creating them as a decimal amount. Okay, so you have your average, 1 standard deviation, 2 standard deviations, 3 standard deviations. Okay, so that's how we run through it. Now the z-score, a lot of times you will have a 1.2 z-score or something like that, and that would mean that you are 1.2 standard deviations away. So for some odd reason in the statistics community, standard deviations wanted to be 1, 2, 3, or -1, -2, -3. Then z-scores come along and goof things up, because then they say, well, let's allow all the decimals and fractional amounts of the z-scores to take place. Okay? So a z-score you can easily find, and it would come out to, so this would be an example of 1.65, which technically would mean that you are 1.65 standard deviations above the average, so that might take place here. Okay? That's the first thing. Is that okay? And I know we've talked about it. I know you're okay with it. And then you can take the z-score and you can use table A. And table A is going to find you the area to the left of whatever that standard deviation would be, meaning how much of the percentage would fall less than you. And then that would, if I were to find, say, go to the z-score of 1.65, that means I'm to the right of the average. I'm 1.65, so I'm between 1 and 2 of the average. So if you use the back table in the back of the book, pretty easy to use. So you're going to look for 1.6. So you go down the left column on the positive side, find 1.6, and then you move it over to 1.6, and then you look for the 05, and you find that it goes to 0.9505. Okay? So that's a portion of 1, and if you wanted to create this and make it as a percent, you just move the decimal 2 places over, which a lot of times the percent can be called something called the percentile. Okay? Now, I'm going to go off cuff a little bit. I'm going to be a little sarcastic. Okay? Sorry, I know it's not like me, but I need to talk to you about something. So a few things that I know about all of you is one day, you and your significant other will choose to maybe raise children. Whether you decide to have children, adopt children, inherit children, I don't know. But I think for the most part, I think most of you are going to probably be involved in some sort of child rearing activity so you have kids, which is kind of cool. And having kids is pretty cool. And the thing about having kids is your kid is the best kid in the world. Now, your friends might look at your kid going, oh, wow. Now, because you are all really nice people, oh, but you still have your phone on. That's pretty rude. Because you are all really nice people, you're going to take your children to the park one day, okay? And you're going to do what most parents do when they go to the park. You kind of scope out the park, make sure there's no broken bottles and syringes and things like that that might be harmful for your child. And if you do find that, maybe you shouldn't be at that park. So you'll find a park that is a child-friendly park. And then what's going to happen is you're going to come across another parent who has also brought their child to the park. You still following me in this adventure? Now, because you are all nice people, you're going to make the nice comment about their child. Hey, you have a beautiful child there. I love your child. Your child looks great. And then what's going to happen is there's this movement of people out there that feel that they need to let you know that their child is gifted. Okay? Now, you might have had these parents that did the same thing, and God bless you, and you're loving for it. But the thing is, this whole gifted thing. Oh, no, my child's gifted. It's a part of the gifted and talented program. And the thing is, if we fell 1.65 standard deviations above the average, which means that 95.05% we're ahead of, is it really that likely that if you have two children both at the park at the same time, that they're both going to fall into the quote-unquote gifted category, falling higher than 95% of the rest of the population? So, if you have the parent that lets you know that, oh, my child's gifted, they speak German, Latin, and French all fluently. You're like, they're two. How do you know your kid's gifted at 2? Oh, they're splitting atoms. No, they're not. Your kids over there eating cat poop they found in the sand. So it is amazing. And you will see this when you go to the park with your own child, and you're going to love your own child, and it's awesome. And you guys are going to have the most awesome kids I know because you're already the most awesome people I know. But you're going to come across that person who's going to have to let you know that their child is somehow better than your child, but they're going to indirectly do it by letting you know that their child is gifted. And if you are gifted as far as the population, you're doing better than 95% of the population at that age. That means that 95% aren't as good as your kid. But they're going to force it down your throat that their child is gifted. And you're going to look at them going, no, your kid is a kid. It's sad. It's really sad. And I will tell you this.
My kid's not a kid.
Well, there's one bumper sticker that's out there that I really like. Saying, my kid can beat up your gifted kid. I kind of like that. Because I'm kind of that, I have kind of that meathead mentality. And I don't have a problem with it.
Like, boosts violence.
I boost violence?
No, that bumper sticker kind of like promotes violence.
Oh yeah, I want to cut that person off. They're the one saying, my kid could beat up your gifted kid. So there are things that I, as a parent, will not do. I mean, I love my two daughters no matter what. They are awesome. I feel they are awesome. They are kids. I now have 3 females in my household, so I'm outnumbered. So I don't get involved if there's a dispute. I know as a 44-year-old dad that how can I be the coolest teacher in the world, the hundreds upon hundreds of kids every year, but my daughters hate me from time to time. And, a lot of times the argument goes on. One of my daughters, her name is May. The other one, her name is Leah. Well, May will come down. She's the younger one. Leah just came into my room without knocking. Oh, here we go. This is a loaded question. This is like when my wife says, do these jeans make my butt look fat? I can't answer that. It's loaded because there's not a right answer. Okay, so Leah came into my room without knocking. Oh, of course, May wants, all hell to break loose on my older daughter so she gets satisfaction and life becomes fair again. But that's not going to happen, right? And I can't win it because then May will go up and do something to her sister, and then her sister will come down and yell at me because I didn't handle something appropriately with her sister, and now her sister's yelling at her. And I just kind of sit there going, all right, I'm just going to watch MASH. It's a good show. Jamie Farr, love that guy dressed in a dress. That I can't act. But It's on Netflix. So guys and girls, I'm going to tell you this. I'm going to tell you this in all honesty. So check this out. Obviously a gifted child right here. Or entitled. Me? Yes, you. That's the subtle hint. Oh. See the yellow circle region? 95.05%. You see that region? I got to tell you, I feel so blessed. Hang on. Ready? I feel so blessed that I am a part of that 95.05% of the population. I'm not part of that gifted population. And you know what? I am so proud to say that my daughters, who I love unconditionally, are also a part of that 95.05%. There's only, in this case, 4.95% of the population that is better than me and better than my daughters. But you know what? I feel pretty darn good about myself that I'm part of that lower 95%. You know what? You all should be proud that you're part of that lower 95% as well, because it's okay. Because you don't want to be part of those. Oh, my child's gifted. My child learned how to drive a car, do open heart surgery, split atoms, and speak 16 different languages fluently before their age of 5. It's not going to happen. But there's this huge population that wants their kid to be that way. All right, so now, this 95% is the area under this. That 95% is all of that region. If I wanted to find the superhero region, if I wanted to find the other region, I am going to take either 100% and subtract 95.05%, or I'm going to take 1 minus 0.9505. And if I do that, that is either going to find me the area as a percent or a decimal of the area to the right. Okay? Remember, the area under the curve is approaching 100%. But that's where we're going to be. So, percentile is the percent of the area. The area under the curve is approaching 100%. If I use my table A in the back of the book, that gives me the area to the left of my z-score. My z-score is another way of saying, hey, what standard deviation above or below the average am I? If I want to find the opposite, the people to the right of where we fell, I subtract either 100% or 1 from our decimal amount. So those are all things I can do. But then I do have this. So then we have that population. Let's say we are given a problem that tells us that this area is 0.3265. We have the area of 3.3265, or 32.65%. So 32.65% of our area is to the left of this curve. So what I want to do is I want to find what my observed value is. Now, let's say things that we do know. Let's say we do know that our average is 70%, and our standard deviation is, 5%. So those are also given. So I know the area under the curve. I know what the average is, and I know what the standard deviation would be. I want to know what the observed score would be. Thoughts? How can I get there? Do what? you're really, really close. Is the 0.3265 the z-score? No, it's the area under the curve. So the z-score is like the standard deviation, right? So by looking at our data, do we think our z-score will be positive or negative, and how would we know? It appears to be negative. Why? It looks like it's to the left of our average. Okay? So I need to, in this point, I need to figure out what our z-score is. What score did we use in order to get to this? So I'm going to go to the back of the book again. I'm going to look at the table, and I'll be like, okay, table, what do we got here? So I'm going to look at all my scores, and you already said, Jordan said that she thinks it's going to be negative. So I'm going to look at the negative scores on table A. So I know I'm going to be negative, and I'm going to find as close as I can the number 0.3265. I'm going to find as close as I can 0.3265. So if I look at negative 0.4, if I look at negative 0.4 going across, I got 0.3446. I get 0.3409. I get 0.3372. I'm getting closer. 0.3336. Oh, wait, maybe go down to the next column. Or wait, go over. 0.3300. That's getting closer. 0.3264. Is 0.3264 pretty close to 0.3265? Could somebody tell me what the z-score of 0.3264 is? It's down towards the bottom center. Negative 0.4 what? Look at the very top number. There you go. Negative 0.45. So make that work. So if you're like, wait a minute, how did we get that? Go down to negative 0.4 and then go over to the 0.05 column. And you're going to find 0.3265. So what is the negative 0.45? What is it? It's the what? Area. Area is the 0.3265. What's the negative 0.45? The what? What's the negative 0.45? What is this? It's not the area to the right. It's the what? Not the area to the left. The area to the left is 0.3265. What is the negative 0.45? What's it called? Z-score. Z-score is another name for standard deviation. Okay, so I'm going to plug negative 0.45 in for Z. I don't know what my observed value is. I know that my average is 70%, so I'm going to go 0.70. Okay, and I know my standard deviation is 0.05. How did I get that? Shh. How did I get that? Yeah, it's given. All right, so algebra 1, here we go. If you have a calculator, help me out. How do I move this 0.045 over, or 0.05? How do I move this over here? Multiply, so what's negative 0.5 times negative 0.05? What is negative 0.45 times times 0.05? How much? 0.025? Is that right? Equals the observed minus the 0.70. The mean. How do I figure out the observed score now? Add 0.7, so negative 0.025, add 0.7 to that. So 0.70 minus 0.025. 0.675. So that means that a 67.5% was earned on a test, if this was a test we were looking at, if we knew what the area under the curve was. We had to take the area under the curve, which was this, find the value as close to it as possible, relate that back to the z-score, which is another word for standard deviation, plug in our standard deviation, which is our z-score, use algebra 1 to go work backwards to figure out what the score of the observed value would be. Okay? Good? You feel okay about it? Now you guys get to get mad at me. Like, oh, you kidding me? I'm already mad at you. I'll start throwing rocks. So, here's the beautiful thing. Is our calculator does this for us pretty easily. It does it for us where we can go back and plug values in to our calculator in order to make it work. Okay, so okay. Let's say we have two scores, 50 and 60. Let's say we as a class we took a test that was a nationwide test. We found that one of the classes scored a certain value, found the other class scored a certain value, or between the two. We want to know what percent of the population scored between these two scores. This particular test was given. Now, I'll do this. This was not the Cherry Creek students that took this. This was the kids at Chaparral that took it. Okay? They're below average. I could say that because I used to teach them. All right, so two different classes at Chaparral High School. One scored a 50% average. One scored a 60% average. Because schools like Cherry Creek were in the mix, the average score of everybody was 75%. So X bar and mu are the same thing. And the standard deviation was 3. Okay? We want to know what the area is between those two. So I'm trying to figure out what this area here is going to be. So now I could do this. I could use the z-score and go with the observed minus that over the standard deviation. I could do it twice. Because here, if I find this, it finds me all the area this way. If I do this one, it finds me all the area this way. If I subtract the two, then I'm going to get the area in between. So let me say that one more time. If I find the z-score of this, that's going to give me the area all to the left of 60. If I find the z-score of this, it's going to find me the area using the table of all the area to the right of this. If I subtract the two areas together, I get the overlapped region, which is that. Sounds fine. But I'm not going there. So what we're going to do, I'm going to show you where to find this on the calculator, because This is more work than it leads to be good up with. So what I'm going to do is I'm going to use my calculator. Bust out the calculator. Calculator, first thing we're going to do, everyone see it okay? Is I am going to hit second vars. Still with me? So second vars. Under second vars, I'm going to find normal CDF, which looks like number 2. Normal CDF. So second vars, normal CDF is number 2. It's going to say lower bound, upper bound, average, standard deviation. Okay? So we're going to use normal CDF, which is going to be the lower, upper, mean, standard deviation. Looking at our diagram, what looks to be obvious as our lower bound? How much? 50? You guys okay with that? So on my calculator, what does my upper bound appear to be? 60, so let's plug them in. So I have 50, comma, 60. Okay? What is my average? 75. So notice I'm using commas to separate it. The comma is right above the 7. 75. And comma, how much? 3 is my standard deviation. Close the parentheses. Hit enter. What does that mean? Pretty small. So this is the same thing as 1, 2, 3, 4, 5, 6. So if I multiply that by 100, which is 1, 2, 3, 4, that's the amount of area that is in between scoring the 50 and the 60. Pretty small area. 10 points between 2 problems. So why is this such a small area? What are we really looking for? Is my diagram accurately drawn to show what this is? So I want you to think about this. Let's do this. Okay? If I were to draw what I have shown here, God bless you. Okay, what percent of my area is between these? What percent of my area is between those? %. Okay, where is 50 and 60 fall in here? Shh. So I'm going to keep this going. So this is going to go 63, 60, 57. So we are like 5, 6, 7 standard deviations to the left of the average score as far as this test goes. So does that make sense to have such a tiny little area? Absolutely. Because within 3 standard deviations of the average, we're talking about 99.7% of our area under the curve. So we're talking about 0.3% of my area under the curve is going to continue to the right and to the left of my score. So my area that's drawn on my thing is, you're absolutely right saying, hey, it's to the left of the average. It's negative, I know that. But using the normal CDF is going to tell you what the area under the curve is. So, what's this normal CDF going to do for us? Absolutely nothing, dude. Okay, so sorry about that. All right, so using normal CDF, which is lower, upper, mean, standard deviation. What is my lower bound as far as this picture represents? Huh? 89. What could my upper be then? I want to know how much area is to the right of 89. So, let's think about this. So I'm going to go second vars, normal CDF. Oops, clear. Second vars, normal CDF. Shh. My lower bound's 89. I want my upper bound to be much bigger. So should I grab 90? No, pick a bigger number, like 1,000, 10,000, doesn't matter. Okay? What did I say my standard deviation is? Or my average? Standard deviation? 80, comma, 7, close parentheses. Enter. So we're talking about 9.9% of the area under the curve. Am I allowed to wow you yet? Can I wow you, please? All right. I'm going to turn my stat plot off. I'm going to change my window on my calculator. I'm actually going to go zoom standard for right now. This takes me -10 to +10, -10 to +10. So as far as my problem went, I want to show this normal curve from, let's see, I have a standard deviation of 7. So if I go to the left, if I go down to like 50, and I go up to like 110 in the x direction, so if I change my window, I go from 50 to like 110. And then go y equals. What was my observed? How much? 89? Comma. Upper bound. Let's go with like 110 because that's where our window's going. Comma, what was my average? 80. What was my standard deviation? 7. Okay, can I do this? Can I make it work? Where's that? Zoom fit 9. I want that under. No. Dang it. This calculator's not going to do it for me. Oh, the calculator should draw the normal curve to show what this area is. But, so the normal CDF will find you the area underneath the curve. So your lower bound is the furthest to the left. If you're talking about an area like this way, make your lower bound pretty low. Okay? So, that's a great question. And then here's going to be your answer. So let's say you had like a or an average of like 5 and a standard deviation of 10. That would obviously go negative numbers. For this, I would, if you had numbers in the 80s or whatever, make it like 0 for your left bound if you needed to. But you could have to go to your 80s. The closer to 0 you make it, or the better to 0, the smaller you make it, you're talking about little tiny pieces of area. So usually if you go like 3 or 4 standard deviations to the left of it, where you need to be, you're going to get a really good area. Okay? And then, do you have one last minute for me? All right, the last one we're going to show is using this key. And this is area to the left. So that means that the z-score was already given, used in table A. Then you're going to take your mean and your standard deviation. So if you already knew that what this area is, so this is like 0.0327, and let's say we knew that the average was 20, and the standard deviation is 10. What value, what gave me this here? And this is the same thing we had worked on. Go back to the z-table, find as close as you can to 0.037, plug it into your z-score, work backwards, or you can do the INV norm. Why did my count? Oh. Dude. Winston, what happened? Did I kill it? All right. Shh. Clear? All right. So if I want to find that area, or what that actual value, the score that gives me that, I'm going to go second vars. I'm going to go to INV norm, which is number 3. I'm going to plug 0.0327 in. I'm going to plug 20 and 10 in. This gives me 1.57. 1.57 is this right here. That's the score you need to get. That would include the area underneath the curve to give me that area right there. Okay? All right. I have gone far enough with you. So, this will be due Monday. 5.3 worksheet, and this will also be due Monday. So meaning, yeah, and I have something for a quiz. Oh, don't worry, I haven't mentioned it. And then 5.4, these are both going to be due on Monday. This is what I was going to do. Your quiz, and I know most of you are going to cry yourselves to sleep about this, your quiz is going to be worth a whopping 10 points. You still with me on this? What? We will be doing the quiz on Tuesday as a class. So people like Logan get the benefit of it. People like Hoban, who aced everything, don't get the benefit. Oh, he's sleeping. Shh, you better keep quiet. He's snoring. Told him to put his phone